All right, in section B of chapter 1.4, we're going to solve quadratic equations by completing the square. All right, so there's a lot of words here, right? And we're going to kind of work through them, and they might make more sense as we go along. But just to summarize the steps in completing the square, this is when you get a quadratic equation in standard form. Now, we should all know what that means because that was in the previous lesson, right? We kind of talked about what a quadratic equation in standard form looks like. Now, you would really only want to try this if the quadratic equation is not factorable. If you can factor it, then that's what you should do. All right? But in any case, right, you can complete the square in with any quadratic equation in standard form, and you'd always start by dividing every term by whatever's in front of x squared if a does not equal 1, right? And this is, you're going to see this isn't always necessary. All right? Once there's nothing in front of your x squared, you can rearrange the equation by moving the constant to the other side of the equation. And then from there, you're going to add, right, this little blank space is going to be for b over 2 squared to both sides of the equation. All right? And then doing that is going to leave the left side of the equation as a perfect square trinomial. And you're going to rewrite it as x plus b over 2 squared. And then you're going to simplify the right side of the equation if you can. And then from there, it becomes exactly what we did in the previous lesson where you're solving quadratic equations by square rooting. All right? Again, a lot of words, but we're just going to work through the examples, and then hopefully they, once you do a couple of them, it kind of clicks. All right? So let's try these first two examples. I'm going to start with this one. Again, the first thing you want to check is that there's nothing in front of x squared. So I just have x squared plus whatever, all right, equals 0, right? And we do have that. All right, the next thing I want to do is I want to move my constant term. So I'm going to say move the c value, right? The c value is your constant term without the variable. So I'm going to go ahead and move that minus 14 to the other side, and I'm going to write plus 14. Opposite of minus 14 is plus 14. All right, so then I get x squared minus 4x, and I'm going to add a little blank space here, and you're going to see why in a second. Equals 0 plus 14 is going to be 14 plus another little blank. All right, I'm going to add the same blank in both spots. And then the third thing I want to do is I want to add, right, b over 2 squared. All right, and that's what we said before on the last page. All right, and in this case, b over 2 squared, b is the number in front of your x. So that b term is going to be negative 4 over 2 squared, which is negative 2 squared. So positive 4. So I'm going to add 4 in that little blank space. All right, so then this side of the equation, x squared minus 4x plus 4 is something that we know how to factor, right? Factors of 4 that add to negative 4 are going to be negative 2 and negative 2. Or I can very simply change that, right? My fourth step is going to change it into x plus b over 2 squared. Right, and b over 2 is this inside of the parentheses. It's going to be negative 2. So it's going to be an x minus 2 squared. All right, and if I put it to one side, I have to do it to the other. So it's going to be 4 plus 14, and that's going to get you an 18. All right. And then from here, this looks exactly like what we did in the previous lesson, right, when we were solving with square roots. Right, so we had in that lesson something squared on one side and then a number on the other, right? So I see something squared, so all I can do from here is square root both sides, putting a plus or minus in front of whatever I just took the square root of. So it's going to be an x minus 2 equals plus or minus the square root of 18. All right, and then I can add 2 to both sides. And so I get x equals 2 plus or minus the square root of 18. All right, so we have x by itself. We're almost done. The only thing that we have to do now is check if the square root of 18 can be simplified a little more, right? And it can, right? If I do 18, right, I can split split that up into 2 and 9, and then 3 and 3, and then 3 is my pair, 2 is all by itself, all right? So then I get x equals 2 plus or minus 3 square root of 2, and then that would be the final answer. All right, so it might be a lot of steps, and you might be a little confused, but the more you do them, the more it's going to click, right? So we're going to try the same exact thing with the next one, right? I'm going to zoom out so you can see everything. All right, and again, we'll do the exact same thing with the next one. All right, so something like number 2. Again, first thing, I don't want anything in front of x squared, right? And we don't, right? So I can move on to the next step, which is moving the constant to the other side, right? Remember, the constant is anything without a variable. So then I have an x squared plus 6x plus, I'm going to put a little blank, equals 0 plus 1 is 1, and then I'm going to add a little blank. And then what's going to go in that blank is b over 2 squared. So it's going to be this 6. It's going to be 6 over 2 squared. And 6 over 2 is 3, so it's going to be a 3 squared, which is 9, right? So that's what I'm going to put in this little space. Right, and the whole point of doing that is so that this becomes a perfect square trinomial, right? We can factor x squared plus 6x plus 9, right, as a perfect square trinomial. So this is going to get me an x plus 3 squared, right? Factors of 9 that add to 6 are 3 and 3. If I have x plus 3 and x plus 3, I can write that as x plus 3 squared equals 1 plus 9 is going to get you 10. All right, and then this looks exactly like something that we did in the previous problem, right? I have something, x plus 3 squared. I have something squared equals a number, so all I have to do is square root both sides of the equation. And then I get x plus 3 equals plus or minus the square root of 10. And then from here to get the x by itself, I would subtract 3 on both sides. So then I get x equals negative 3 plus or minus the square root of 10. The very last thing we want to do is see if 10 can be simplified. It cannot, right? Factors of 10 are just 2 and 5. Can't break those down anymore, and nothing matches, so I don't need that at all. This would be the final answer. All right. So hopefully as we're going through these steps, it's not horrible, right? I know it's maybe a lot more than what you're used to, but it's still the same steps every single time. All right, so hopefully not too bad. All right, and we'll try a couple more just like that, right? The only way it's going to change is, we'll show you, right? The next 4 examples after this page are a little bit different, all right? But I'm going to do the exact same thing with these, all right? Once again, I don't want anything in front of x squared. I don't, so I'm going to go ahead and add 5 on both sides. Add the constant without the variable on both sides. And so I get an x squared plus 2x plus a blank equals 0 plus 5 is 5 plus a little blank, all right? And then what's going to go in this blank is going to be b over 2 squared. My b term is whatever's in front of the x, so it's going to be 2 over 2 squared. 2 over 2 is 1, so it's going to be a 1 squared, which is 1, right? 1 times 1 is 1. And then that's what's going to go in each little blank. And then this expression right here, this is going to turn into x plus 1 squared, right? Factors of 1 that add to 2 are 1 and 1. Or you could have just used whatever was in the middle here, right? b over 2. It's always going to be x plus b over 2 squared. Equals 5 plus 1 is going to get you 6. I can square root both sides now. And then what this is going to leave you with is an x plus 1 equals plus or minus the square root of 6. All right, very last thing we want to do, well, not the very last, right? We're going to subtract 1 on both sides, and then I get x equals a negative 1 plus or minus the square root of 6. All right, now the very last thing you want to do is check if the radical can be simplified. And in this case, the square root of 6 cannot be simplified, so we're good. All right, 6 is not a perfect square, and it doesn't have any factors that are perfect squares, so I would leave it alone. All right, Hopefully not too bad now that we've done a couple. Right, we're going to do the next one exactly the same way. So I'm going to go ahead and subtract 5 on both sides. Oh, sorry, subtract. All right, I want the constant on the other side. And so I get x squared plus 6x plus a blank equals -5, all right, plus a little blank. And then what's going to go in that little blank is b over 2 squared. So it's going to be 6 over 2 all to the second power. And this is going to be 3 squared, which is 9. So I'm going to add 9 on both sides. All right. And then this is a perfect square trinomial. Again, it's always going to be x plus b over 2 squared. So x plus 3 squared. All right, equals -5 plus 9 is going to leave you with a positive 4. So then I can go ahead and square root both sides. So then I get x plus 3 equals plus or minus, the square root of 4 is 2, so I can just immediately write the 2. All right. Very last thing we do is subtract 3 on both sides, and then I get x equals -3 plus or minus 2. Right? Think about one example that we did in the previous lesson, right? I don't see any radicals in this problem, so that's probably some indication that we can split up these plus and minuses and turn them into nicer answers, right? Again, keep in mind plus minus means 1 is plus, 1 is minus, so it's going to be a -3 plus 2 and a -3 minus 2. All right, and -3 plus 2 is going to get you a -1, and -3 minus 2 is going to get you a -5. All right, so we actually get 2 integer answers. Right, what that means is maybe in the very beginning you could have factored this, right? Factors of 5 that add to 6 are going to be 1 and 5. So we could have done this entire problem without having to complete the square, right? We could have very simply just done x plus 1 and x plus 5 equals 0. And then have done x plus 1 equals 0 and x plus 5 equals 0. Right, so unless we tell you on the test or the quiz to solve by completing the square, you don't have to, and that should always be the first thing that you look for. The first thing should always be to check if you can factor that expression, right, once it's written in standard form. All right, so that's the only way that it gets a little bit different. And then we can't do anything else with anything that has a radical. So for instance, something like this answer in number 3, if I tried splitting it up and I did -1 plus the square root of 6 and -1 minus the square root of 6, I wouldn't have been able to do anything with that, right? Because you can't combine an integer with a radical, all right? So that's why in this case we can split it up and get 2 answers, and in this case we couldn't, right? We could get 2 answers, there's just nothing more we can do with them, all right? So hopefully that distinction is clear. All right, we'll do a couple more. Again, the very first thing is always looking for if there's anything in front of the x squared. There isn't in this case, so we always now want to add the constant to the other side, or move it to the other side. So plus 6, and then I get x squared minus 3x plus a blank equals 0 plus 6 is another 6, right, plus a blank. All right, and then in this case, when you do b over 2 squared, a little bit different, just now we get a fraction, right? So -3 over 2, right? I can't simplify that anymore, so I'm just going to have to square a fraction, right? Squaring a fraction, you can just square the top, square the bottom, or you can just write it twice, right? -3 over 2 times -3 over 2, right? That's what a square means. And then you can do top times top, bottom times bottom, and that's going to get you a 9 over 4. So I'm going to put 9 over 4 in that little space right there. All right, and then now you can factor this side, but you don't want to find factors of 9 over 4 that add to -3, right? That's going to be super tedious and that's going to take forever. What you always do instead is you use b over 2, right? Whatever b over 2 was that you squared, right? So before you squared it, you got something, right? And it's always going to be that number. So it's going to be x minus 3 over 2, right? That's the number that was inside of our parentheses. I kept the sign with it, the minus. So it's x minus 3 over 2 squared equals 6 plus 9 over 4, right? With that, I can find a common denominator, right? I don't want to deal with it the way it's written like this. I want to try to get it a little bit simpler. So I want to write this 6 over 1 and then find a common denominator, right? This one has a 4, this one has a 1, so I can multiply the top and the bottom by 4. And then what that's going to leave you with is 4 times 6 is 24. So I get 24 plus 9, which is 33. So then what we end up with is x minus 3 over 2 squared equals 24 plus 9 is going to get you 33 over 4. All right, a little bit more tedious now that we have a fraction, right? But that was the only thing that we had to look out for, right? From here, it's the same as before, right? I can just square root both sides and then throw a plus or minus in front. So then I get x minus 3 over 2 equals plus or minus the square root of 33 over the square root of 4. Why did I split it up? Because we can simplify now the square root of 4, right? And you can always do that when you're dividing under a radical. You can square root the top, square root the bottom. So then I get x minus 3 over 2 equals plus or minus the square root of 33 over 2, all right? And then from here, you can add 3 over 2 to both sides to get the x by itself. And then I get, let me write it on this side here. It's going to be x equals 3 over 2 plus or minus the square root of 33 over 2. And then you can write your answer like this. This is perfectly acceptable. Or you can also write it as 3 plus or minus the square root of 33 over 2, right? If they both have the same denominator, you can do this. You can write them under the same fraction. So both of these are equally correct. All right, one of them isn't better than the other. We don't prefer one over the other. It's just one is under a single denominator and the other one isn't. All right. All right, we can do the exact same thing with 6. 6 is where it gets a little bit different, just because see what's in front of that x squared. I see a negative, right? We don't want a negative in front of the x squared. We only really want to complete the square when x squared is positive and there's nothing else in front of it. So what I can do to this entire equation is I can divide everything by -1. If I divide every single thing by -1, then that turns whatever is negative in front positive, right? So that becomes a positive x squared. So I get x squared, 3 divided by -1 is -3. 5 divided by -1 is -5, equals 0 divided by anything is 0. And now this looks like something that we can now complete the square. So I'm going to go ahead and add 5 on both sides. All right, just repeating our process. So it's going to be x squared minus 3x plus our blank is going to equal 5 plus our little blank. And then again, I'm always going to do b over 2 squared, so something like -3 over 2 squared, which is 9 over 4, right? It's exactly the same as we did in the previous one, coincidentally, right? So it's going to be 9 over 4. And then this side, again, you don't want to waste your time trying to find factors of 9 over 4 that add to -3. We already know what they're going to be. It's going to be -3 over 2. So I'm going to write x minus 3 over 2 squared equals, and then I can do the same thing as I did before, and I'm going to write this 5 over 1, and then multiply the top and the bottom by 4. So 1 times 4, 5 times 4. All right, and then 4 times 5 is 20. 20 plus 9 is going to get you 29. So I get 29 over 4. And then now I can square root both sides. And so I get x minus 3 over 2 equals plus or minus the square root of 29 over the square root of 4. But the square root of 4 is 2, right? So I can square root the top, square root the bottom. So this is going to get me square root of 29 over 2. All right, so now that the radical is fully simplified, I can go ahead and add 3 over 2 to both sides. And so I get x equals 3 over 2 plus or minus the square root of 29 over 2. And then that's my final answer. That's perfectly fine. Another thing that you could do, just like before, is you could write them under a single denominator. So I can write x equals 3 plus or minus the square root of 29 over 2. All right, and that's perfectly fine as well. All right. Now these last few problems get a little bit tricky. All right, so these are not ideal for completing the square, but I'll show them to you anyway just because, I don't know, those of you that like to challenge yourself a bit maybe want to explore other methods of doing these kinds of problems, right? So I'm going to try this one. Let's try number 7. Right, so again, just like in the previous problem, I don't want anything in front of that x squared, so I'm going to divide everything by what I see in front of it. So divide everything by 3. And then so now I get an x squared plus 2/3 x minus 5/3 equals 0. And then again, I can do the exact same thing as before and add 5/3 to both sides. Right, now this is really not pretty, right? This is all fractions from the beginning. So then I get x squared plus 2/3 x plus a blank equals 5/3 plus a blank. And then I'm going to do the exact same thing. I'm going to do b over 2 squared. Now when I do 2/3 over 2, right, most people get that and they don't know what to do with it. All right, you would really write this 2 over 1 and then you would keep change flip because you're dividing fractions, and then you would get 2/3 times 1/2. Or you could have started here, right? You could have started at 2/3 times 1/2, right? Because hopefully we know that multiplying by 1/2 is exactly the same as dividing by 2. All right, so then I get 2/3 times 1/2, which is going to get me 2 over 6, which simplifies to 1/3. So I'm squaring 1/3, right? b over 2 squared. And this is going to get me 1/9. All right, so a little bit of a process now to get whatever that number is. All right, but it's still going to factor the same way. This right here, this is going to become x plus b over 2 squared, right? So b over 2 in this case is 1/3. All right, so it's going to be x plus 1/3 squared equals 1/9. Wait, no, sorry. Equals 5/3 plus 1/9. So I'm going to do times 3 times 3. All right, and then 5/3, 5/3 becomes 15 over 9. And then 15 plus 1 is going to get you 16 over 9. And then I can square root both sides. And then I get x plus 1/3 equals plus or minus the square root of 16 over 9 is the same as square rooting the top, square rooting the bottom. Square root of 16 is 4, the square root of 9 is 3. All right. And then last thing we can do is I can subtract 1/3 on both sides. All right, and then so I get x equals negative 1/3 plus or minus 4/3. Right, I don't see any radicals in this problem, so I can do what I did before and I can try to split this up and get 2 answers that way. So I get 1 over 3 plus 4 over 3, and then I get negative 1 over 3 minus 4 over 3. And then negative 1 plus 4 is going to get me a 3 over 3, which is 1. And then negative 1 minus 4 is going to get me a negative 5 over 3, which doesn't simplify. So then these would be my 2 answers. All right, so a little bit of work to get to that. But again, just like I said before, what this means is that you probably could have just factored it from the beginning. I could have done 3 times negative 5 and found factors of negative 15 that added to 2 and have factored it, done the slide and divide. Again, you don't want to waste your time doing something that takes forever, right? This was really time consuming. All right, but it's good to see how we can do it because not every problem you can factor, right? Sometimes you're going to want to complete the square to try to get something that you can square root, or the next lesson is going to be using the quadratic formula. All right, and those are the only 2 other ways that you can solve quadratic equations without factoring. All right, so I'll try one more just for the sake of finishing our lesson, right? I want us to try one more. I know it was a little challenging, right? But let's try the exact same thing, right? I'm going to divide everything by whatever's in front of x squared I don't want anything in front of it, so I'm going to divide everything by 3. So then I get x squared minus 4 over 3x minus 1/3 equals 0. All right, and then I can add my 1/3 to both sides. And so I get x squared minus 4/3 x plus a blank equals 1/3 plus a blank, right? And so now I can do the same exact thing as before. I can do b over 2 squared. So I'm going to do negative 4 over 3. I can divide by 2 like this, or I can say that this is negative 4/3 times 1/2. All right, and then 4 and 2 are going to simplify. That's going to become a 2. And then I get negative 2 times 1 over 3, so that's just negative 2 over 3. All right, and then I want whatever's squared to go in this little blank spot. And again, squaring a fraction, I can square the top, square the bottom, so this is going to get me 4 over 9. So 4 over 9 is going to go in this little blank spot. All right, and then this is going to become x minus 2 over 3 squared. All right, if you're wondering how I got that, it's always going to be whatever you just squared. If I'm squaring negative 2 over 3, then that's what's going in the parentheses with the x. Equals, and then I want to simplify 1/3 plus 4/9. So times 3 on the top and on the bottom. 1 times 3 is 3, and then 3 plus 4 is 7. So I get a 7 over 9. And then from here I can square root both sides. So square root, and then I get x minus 2/3 equals plus minus, right? Square root of 7 over 9, I can do square root of the top, square root of the bottom. Square root of 7 doesn't simplify. The square root of 9 is 3. All right, and then I can add 2/3 on both sides. And then we get x equals 2/3 plus minus the square root of 7 over 3. And then that would be your final answer. Right, and again, just like before, you can, if you want, write it under a single fraction. Right, they both have the same denominator, so I can write 2 plus minus the square root of 7 over 3, just like that. All right, so they get a little tedious when it's not as straightforward. All right, but there's some cases where it does work, and I'll talk about that in the next slide. All right, so the best way to use completing the square is when a equals 1 already, when you don't even have to divide anything. And the other thing that we want is the middle term b to be even. But as you saw, it can be used in any case. But the next lesson, quadratic formula, might be better in some cases. Maybe you don't want to do completing the square. You'd rather use the quadratic formula, right? A lot of kids love the quadratic formula, all right? But you should use all methods and recognize when a method is best used versus another one, right? Because if, let's say, on a test or on a quiz, we say solve by completing the square, right? Maybe that's what we say as the directions, then you have to use that method, right? Otherwise, you won't get full credit, right? We do that in honors, and we did that last year in this class, all right? So there might be a question that's going to say solve by completing the square. Is it going to be a crazy hard one? Probably not, right? We're probably going to do something like where a is 1 and b is even, right? Just so that you have an easier time getting your answer, but so that you still know how to complete the square, right? It's a good method to learn how to do, all right? But that's all I have to say on this lesson. The next lesson we're going to finish solving quadratic equations. We're going to do the quadratic formula.